Hello everyone. Today we are going to study about law of variable proportion. This law examines the production function in short run. Here we study the production process by keeping one factor variable and other factors fixed. It states that as equal increments of a variable factor are combined with a given quantity of fixed factors, the marginal and average product of the variable factor will eventually decline or decrease. Which means with the combination of the fixed factor that we have, along with that, as we increase the amount of variable factor, this combination would eventually lead to the average and marginal product of variable factor to reduce. This is the tabular representation of law of variable proportion. As we can see, here land is taken as the fixed factor and labor is taken as a variable factor. It is assumed that 1 unit of land is being used in the entire production process. This table consists of 4 columns, as we can see. The first column shows us the units of labor employed in the production process. That means the total amount of variable factors that are being employed in the production process, which is increasing. Then the next 3 columns shows us the total product, average product and the marginal product. We are already familiar with this concept, but let us recall. Total product may be defined as the amount of aggregate output produced by all factor inputs. That means as the units of labor employed increases, total product increases. Next is average product. Average product is defined as the output produced per unit of variable factor. Next is the marginal product. It is defined as the addition made to the total product by employing one extra unit of variable factor. Now, with a given fixed quantity of land, which in this case it is taken as 1 unit, when labor employed increases from 1 unit to 7 units, total product increases from 10 units to 80 units. The total product reaches its maximum at when the 8th unit of labor is employed. That time it is maximum at 80 units. Now an interesting fact over here is when the first 3 units of labor are employed, total product increases at an increasing rate. And from the 4th unit to the 7th unit of labor employed, total product increases at a diminishing rate. How do we come to know about that? It is through the marginal product. As we can see, in the first 3 units, when the first 3 units of labor are employed, total product is increasing, marginal product is also increasing. But from the 4th to the 7th unit of labor, when total product is increasing, marginal product is declining, which means that marginal product measures the rate of change in total product. At the 8th unit of labor employed, total product is 80 and it is at its maximum, and the marginal product becomes 0. Why? Because from the 7th to the 8th unit there is no change in total product, which is why marginal product is 0. And eventually beyond the 8th unit of labor is employed, that is the 9th unit of labor, total product declines, it becomes 78 and marginal product becomes -2. That means it becomes negative. And meanwhile, all through this, the average product, it first increases, reaches its maximum at the 4th unit, and then it starts declining. It is positive throughout and it never becomes 0. This is the diagrammatic representation of law of variable proportion. As we can see, the x-axis represents the units of labor employed. And the y-axis represents total product, average product and marginal product. Here we see there are 2 different diagrams, but they're actually the same. In order to avoid any kind of clumsiness and for a better understanding, they have been showed in two different diagrams. This is the total product curve. This one is the marginal product curve, and this one is the average product curve. All these three curves can be clubbed in one single diagram, but just to avoid any kind of clumsiness, they have been divided into two different diagrams. According to this law, the entire production process has been divided into three stages. Stage 1 is known as the increasing returns, stage 2 is known as the diminishing returns, and stage 3 is known as the negative returns. All these three stages are shown on the x-axis of this diagram. ON, stage 1 increasing returns, NM, stage 2 diminishing returns, MX, stage 3 negative returns. Now, with a given amount of fixed factor, when units of labor are employed, total product starts increasing. We see that the total product is increasing, the total product curve is increasing from its origin. It increases at an increasing rate till point E, and beyond point E, it increases at a declining rate till the end of stage 1. The point E is known as the point of inflection. Why is it known as the point of inflection? Because at that point the curvature of the curve changes. You see, before point E, it was at an increasing rate. It was increasing. In both the cases it is increasing. Till here to here it is increasing. Till here to here also it is increasing. But till O to E, it was increasing at an increasing rate. And from E to till the end of stage 1, it was increasing at a diminishing rate. So, you see, increasing rate, diminishing rate, which is why, and that changes at the point E, at the point of inflection. So, yeah, it is the point where the curvature of the curve changes. Now, meanwhile, we see the marginal product curve. Well, it increases, it starts from the origin, it increases and it reaches its maximum at the point of inflection. We can correspond it vertically. This is the point of inflection. It reaches its maximum at the point of inflection, and then beyond the point of inflection it starts declining till the end of stage 1. Here, as we already know, that marginal product, it measures the rate of change in total product, because when the rate was increasing at an increasing rate, marginal product increased, and when it increased at a declining rate, marginal product starts falling. And as for the average product, it increases and it reaches its maximum at the end of stage 1. Now about stage 2, it is known as the diminishing returns. In stage 2, the total product continues to increase at a declining rate. Whereas the marginal and the average product, they are falling, but they are still positive. By the end of stage 2, total product reaches its maximum, and marginal product, it becomes 0. It touches the x-axis. And about average product, it's still falling, but it is positive. Now in stage 3 is known as the negative returns. In stage 3, we see that as more of variable factor, that is labor, is employed, total product starts falling. Marginal product crosses the x-axis and becomes negative, and average product is still positive, but it's falling. So these are the three stages of production. Now I'm going to explain you how the various stages of production operate. But before that, let me explain the relationship between the inputs and the outputs. Now the factor inputs used over here are land and labor. These inputs are used to produce a given level of output, which in this case is agricultural output. But when we use too much of a particular input, it does not contribute much to the productivity of the output. In fact, with time, when the number of input is increased, the productivity of the output actually reduces. This is what happens in this particular law. In the first stage, when there is both land and labor and they're combined, both the factors get completely and appropriately utilized, which is why the productivity or the total product increases at a rapid rate. But eventually, the quantity of land being fixed, when more and more labor are employed in the production process, eventually the contribution to the total product starts reducing, and that is seen in the reduction of the marginal product curve. And eventually by the third stage, by the end of the second stage and by the beginning of the third stage, we see the amount of variable factor or the labor used is so high that it no longer contributes to the productivity of the output, which is why total product declines and marginal product becomes negative, and average product also starts falling. Hence, this law is a perfect example of a proverb that we have heard many times, that is, too many cooks spoil the broth. That means when too many people are involved in a work, they rarely or they hardly contribute to the productivity of the output, because when too many people are involved, eventually the productivity of the output declines and the end result is unsatisfactory.